Now we're going to talk about the physical properties and chemical properties of aldehydes and ketones. When I was talking about and introducing the previous section, I talked about this carbon-oxygen double bond. And once again, if we look at the periodic table, fluorine is the most electronegative element. It's in the upper right-hand corner. Oxygen is right next to it. That means it is really close to electronegativity as fluorine. Whereas carbon is over here, and it has less of the pull of the electrons. So what this is saying here is that the electrons are drifting from carbon towards the oxygen. Because of that, it's giving it a partially negative charge. That's what this symbol means. And this symbol means partially positive. Now, because of that, it's going to be able to interact with polar substances such as water, but not 100%. Notice there's a cutoff at 4 carbons for both the ketone, and the aldehyde, and the ketone. After 4, it becomes insoluble. Now, what's going on here is that the aldehyde and the ketone both have this positive-negative interaction with this oxygen because of this oxygen. Now, as a result, this is giving it a partially negative charge. This is a water molecule. When we look at a water molecule closely, the oxygen, once again, is close to fluorine on the periodic table, whereas hydrogen is all the way over here. The electrons are drifting towards the oxygen, which is leaving that hydrogen partially positive and the oxygen partially negative. Notice we have a positive and negative again. So the negative of the oxygen in the double bond is being attracted to the positive of the water. That's forming what's called a hydrogen bond. Notice hydrogen bond is not a true bond. It's actually an attraction between that partially positive of hydrogen and partially negative of oxygen. It's just an attraction that contains hydrogen. It's not a true bond. If we look at the ketones, same situation applies. The negative from the double bond is being attracted to the partially positive of the hydrogen in water. So if we look at determining which is soluble and which is insoluble, first thing you want to ask yourself is, does it have oxygen? And if the answer is yes, then the next question you have to say, is it more than 4 carbons? If the answer is yes, then it's insoluble. If the answer is no, it's soluble. So this has no oxygens in it, so therefore it is insoluble. This one has an oxygen and it's less than 4. So that means it is soluble. This has oxygen, and it has 4. It's soluble. It might say slightly soluble. And then we have 3 with an oxygen. That, once again, is soluble. And once again, this is slightly soluble, but it's still soluble. Now, if we take a look at what we did in the previous chapter, we can look at the oxidation of the alcohols. For instance, every time it oxidized, we increased the number of oxygen bonds and decreased the number of hydrogens. There was a hydrogen here before that's not there. There was a hydrogen here before that's not there now. So when we do that, it is primary alcohol. Here's the carbon OH bond. Hydrogen, hydrogen, carbon. It's only bonded to one other carbon. That's what's making it a primary. When you convert it and oxidize it increase the number of oxygen bonds and decrease hydrogens, you're creating an aldehyde, which is what we're talking about in this section. And then if we do it again, to oxidize it, we're going to increase the oxygen by putting an OH in there. And that forms a carboxylic acid. So aldehydes, when they oxidize, become carboxylic acids. When we have a secondary alcohol, there's the alcohol bond. We have a carbon here and a carbon here. This one doesn't count because it's not carbon. So we have 1, 2 carbons here, which is making it secondary. If we do away with the hydrogens and increase that oxygen bond, like we did here, we have carbons on either side. That's making a ketone. So primary alcohols will oxidize to aldehydes and then further to carboxylic acids, whereas secondary alcohols will oxidize to ketones. So if we're looking at this, that was the review. Primary alcohol, because it's only bonded to one other carbon, oxidizes to ethanol, because now it's an aldehyde. And then it goes further to a carboxylic acid. Secondary alcohol, here's the alcohol, carbon here and a carbon here, that's making it secondary, will oxidize to propanone, which is a ketone. And then it stops. So we can actually do tests as chemists to see whether or not there are aldehydes in solution by oxidizing it. Because a ketone will not oxidize further, but an aldehyde will. It'll go from an aldehyde to a carboxylic acid. Notice that we have the double bonded oxygen, and we throw another oxygen into the OH. And if that's true, if that happens, an aldehyde is there originally, and silver is made. And that is actually a way that you can make a silver mirror. Another test which is extremely similar. Here's your carboxylic, or here's your aldehyde. If we oxidize it, we're going to put an oxygen right before that hydrogen. Because it's an aldehyde, you can do that. So if it's not an aldehyde, this reaction won't go. But if it is an aldehyde, we're going to see a color change. For instance, here it is before it oxidized, here it is after. Reduction means that we're adding hydrogen to the process. So before, with oxidized, we would be putting this double bond here. With reduction, we're removing that double bond, and we're putting those hydrogens back. Same with the ketone. If we reduce it, we're putting that hydrogen back where it was. So write the structure and name of the organic product when each is mixed with Tollens reagent, which means is oxidized. That's what you're looking for. So bute means 4 carbons. Butanol means that it's an aldehyde. That means the last one looks like this. Well, if it's oxidized, you're going to insert an oxygen into there. So carbon, 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 carbon. Still have that double bonded oxygen, but now we have an OH here rather than just an H. Name it. 1, 2, 3, 4. Butanoic acid. Acetaldehyde, which was one that we had to memorize. It has 2 carbons, and it's an aldehyde, so that means the last one. Looks like that. We're oxidizing it because of this hydrogen here. You can. And here you go. That's acetic acid. Ethyl methyl ketone. So here's the carbonyl. On one side we have ethyl. On the other side we have methyl. Because there's no hydrogen down here, there is no reaction. It cannot be oxidized further. And here we go. Because we didn't actually talk about how to name carboxylic acids, I'm not going to worry about that right now. Just know that when you have a aldehyde, you insert an oxygen to make a carboxylic acid when it oxidizes. This is actually written wrong. That oxygen should not be there. And that is properties of aldehydes and ketones.